So hello future achievers. The last session we have seen about the conductor and we have solved a lot of problems. We have also solved some problems. Now we are going to proceed our session with a one important, very important concept, that is one important concept that is have been left, and it is very important for the J advanced point of view, and it is very important for the NEET and for the theory as a, because it is going to be asked for the theory concept. So we will see that concept and then we will move to the conductors and we will solve some here. So the concept is very simple. This is the concept. Basically, yesterday we have solved the last session, or you can say we have solved the some question on the cavity. So what is the concept is saying? The concept is state that if there is a one conductor and I am giving a cavity here, and suppose this this distance from the radius of this outer cell is A, and the radius of the inner cell is B, and this is my cavity. And suppose the distance between the two center point is L, and there is a one position at this position R1 vector and this position R2. I want to calculate the electric field inside the cavity. So if you apply this thing, see electric field due to this whole sphere, outer sphere, I will break into the two different parts that we know. So if I find the electric field at R1 point, it will be rho R1 by 3 epsilon naught, correct? Similarly for this one, it will be minus rho R2 because it will be minus rho. I told you how to solve it. First you divide it into plus rho and another one you minus rho. Then E net will be this thing. Now if you see this triangle, we have R1 vector here, R2 vector here. So obviously my L vector will be how much? That is R1 vector minus R2 vector, correct? Just you put it here. So what is the observation you will get? This is rho L by 3 epsilon naught. You will get the net electric field inside the cavity. So inside the cavity, what we have understand, inside the cavity, the net electric field is a constant. It is a constant. And on this concept only, JEE Advanced have been asked the some question also, and also there is a one question from the Olympiad. In physics Olympiad, they have asked one question, and in the NEET, they have asked us some theory question on this concept. So you should remember this concept, very important. It is a very important concept. Mostly for J advanced point of view, it is a very, very important. Okay, as we are covering for every exam, so this is an important concept. And if you want to solve that question, that International Physics Olympiad question, I will give it to you in the end of this lecture. Okay, like not in this lecture, in the end of this this complete chapter I will give it to you. Okay, so yeah, this is the concept we understand. Inside the cavity, the electric field is constant, that is rho L by 3 epsilon naught. Okay, now the next thing we are moving toward is the next concept is the problem on the cavities. So basically what is the thing here? Suppose I have a conductors, but I am giving a cavity inside this conductor, and this radius is R1, this radius is R2. Basically what I did, first I given a charge Q on this surface. So obviously we have seen the concept that this charge is going to be divided completely and uniformly over to the outer surface. There will be no charge present inside, and that we have seen also. There is a reason for it, because if you take the Gaussian surface in this region, you will get electric field is equal to 0, because electric field, whenever there is a material is there, the electric field has to become 0, and there is a reason for that, and that we have discussed in the previous lectures. If anyone have a doubt, go and see the previous lectures. Okay, so yeah, this charge will be distributed uniformly. So if I want to calculate the electric field at point A, so what is the electric field at point A? It will be 0. Why? Because the Gauss law, there is a no Q in, so electric field will be 0. What is the potential at this? There is a electric field is 0, so potential has to be constant. Now the question is, what is that constant value? That is due to this Q only, and it is an inside point, so it is KQ by R2, correct? Similarly, that is what is the electric field at B? Obviously this is a material point, so the electric field at B will be equal to 0, correct? Because it is a material point, so electric field at B will be obviously equal to 0, correct? Similarly, what is the potential at B? See, electric field is 0, that means potential has to be constant, and obviously it is an internal point for this Q, and this will be KQ by R2, that we know. Then we come to the C point. C point is a very easy point. For that, the charge Q, the electric field will be KQ by R square, and the potential will be KQ by R, that we know. So that is the concept for this. Now let us understand one more concept, the extended version of this. In this case, what I have did, in spite of giving the charge on the outer surface, I have keep the charge in the center. Suppose I keep the charge Q in the center, then what will happen? As I keep the charge Q on the center, what is going to be happen? Let us understand in very detail and very slowly. Basically what is going to be happen, if you take the small Gaussian surface just outside this inner sphere, you will see that as it is material, so the electric field has to be 0. That is sure. If the electric field is 0, my total flux has to be 0. If the total flux is 0, can I say my total charge inside this surface has to be 0? That is true. But here we are seeing plus q charge is there, na? So how the total charge is 0? That means there will be some minus q charge should be induced on the inner surface. That is why I induces a minus q charge on this inner surface. But tell me, initial charge is how much? Initial charge on the conductor is 0. There is a charge in the cavity. There is no charge initially on the conductor. So initial charge on the conductor has to be 0. But now as we have induces a charge minus q on this conductor, so there is a total minus charge q has been induced on the conductor. So to neutralize that charge and bring the charge conservation, there will be plus q charge will also induce on that outer surface. So that is a charge distribution will happen. And finally this system will equivalent to this system where we have a q charge at the center, then minus q charge on the surface S1 and the plus q charge will at the surface S2. Now for this system it is very easy to write the electric field potential and everything. Just I have written here also, you can see now, because this lecture is need more explanation, so for that is why I have written everything first and then I am trying to explain you the thing, because here you have to understand the things more. If I write, I cannot explain you properly the each and everything, so that I can explain each and everything properly. See, if you see here there is q, minus q and plus q. If you talk about q S1 S2, then net we will calculate. See, first thing is that at center, at point A, let's talk about. At point A, due to q, what is the electric field? Don't forget about everything, just see due to q what will be the electric field. That is kq by r square, correct? Now r is some general distance. Now due to minus q, or you can say due to S1, what is the electric field at point A? As we can see, the point A is an internal point, so the electric field has to be 0. So that means the electric field will be 0 because it is an internal point of conductor S1. Similarly for S2, if you will see, this is again an internal point of the conductor S2, so it will become again 0. So my net value will be kq by r square. Clear? Similarly, let us talk about the potential at point A. If you talk about the potential at point A, you will see that the point A, for this charge q, it will be a kq by r, simple. But if you come to S1, you will see this point is internal point, and for internal point the potential has to be constant for the conductor, so it will be minus kq radius of r1, correct? Now for S2, again it is an internal point, so what is the value? Kq by r2, so that is kq by r2. So total value you will get something like this. So this is the total potential at this point, inside this point, correct? Okay, now let us talk about the point B. Point B is this point. So obviously by common sense we can say, or by the concept which we have learned, we can say the electric field at point B will be 0. Why? Because it is in the material. But let us check this, whatever we have read is correct or not, whether whatever I am teaching is correct or not. So let us see. Due to this plus q, this internal charge q, what is the electric field at point B? Some kq by r square, some general distance r square. Now what is the electric field due to this minus q at this point B? Again it will be some minus kq by r square, because I am writing vector form, so I am considering the direction, so I am that way there is a minus sign will be, because due to this electric field will be in this direction, due to plus q minus q it is in this direction, correct? But what is the electric field due to S2? Obviously due to S2 it is an internal point, so it has to be 0, so obviously the electric field will become 0. So what is the total electric field? If you add, you are getting 0. That means whatever we have read and whatever we have understand, it is totally correct. Similarly, come to the potential. Again, now you can write the potential by itself. See, by yourself only. At point B, due to q, it is a general point, so kq by r. Similarly, for S1, it is an outside point and general point minus kq by r. Similarly, for S2, but S2 it is an internal point, so constant value, so kq by r2. So you will get net as kq by r2. Similarly, again come for electric field at point C. How to calculate at point C? At point C is very simple. What you have to do, it is an outside point, so you can directly write kq by r square minus like that, because it is a general outside point, so outside point there is a no problem. Clear? So we have understand, basically we have understand how to analyze the electric field potential at any point, and if I give you any question you can now tell. Now let us move to the next concept. Next concept, what we like, one more thing. If you see here, what is the thing you are getting? If you see the outside point properly, see outside point is this. due to the plus q, inside plus q it is kq by r square, minus q again it is minus kq by r square, plus kq by r square. So electric field you are getting is kq by r square. Similarly here also potential again the same thing. So what you observe, that is my electric field and potential is independent of whatever the charge that is present inside. It doesn't matter because these two values are getting added and cancel out. Only the outer thing is coming, means outer whatever the contribution from outer charge is coming into the E net. So from here what we have observed that the external means if we have a E net or V net, there is a only contribution of the external charges, there is a no contribution of the internal charges, nothing, they don't contribute on that. There is a contribution but they are automatically net value is becoming 0 due to them. So there is a no contribution total overall. So what is the observation from here get? From here we are get a very good property that is called as a electrostatic shielding. What is electrostatic shielding? The external electric field due to the Q is not going to be affect the internal charge. Okay, this property of conductor is called as a electrostatic shielding. Means what I am trying to say, see there will be electric field due to the two things. First is suppose this is the external electric field and suppose this is my Q, due to which this also outer charge Q is there, there will be some electric field due to these two. These two electric field is not going to be affect this charge, because why? Because there is no contribution is there na, so obviously they are not going to affect them. If it is not going to affect them, so whatever is the charge, there will be there is a no contribution of these two on side this inside this charge. So that property is called as a electrostatic shielding. This property is only termed as a electrostatic shielding. Okay, this property is termed as a electrostatic shielding. Clear? Any doubt? And if I try to draw the charge basically electric field line, and suppose my charge is here, it is not placed at the center, this is placed slightly away from the center. So you can see that the electric field lines will be like this. There will be electric field lines outside and the electric field lines inside. Basically I have placed the charge little not toward the center, little away from the center. Okay, it is slightly here, it is slightly here from the center. So that's why electric field lines will be like this. Why I have drawn? Because it is a, in JEE they have asked this question. Basically they have given, and they have given the option. So just for your information I have tell you, and you can see properly there is a no electric field line inside this material, because here we have electric field is equal to 0. I hope it is clear now. Now if I have given for you, I have given one example homework also. I have given the charges and I have asked you to write, to make the table like this. You have to make the table like this you have to write everything for this configuration. Okay, again for this configuration you have to write everything. That is a homework for you. Now let's move to the next concept. The next concept is a concept of charge transfer. My question is that if suppose I am connecting a two conductors, obviously their potential, suppose their potential are different, one has a higher potential or one has a lower potential. That is show that if there is a potential difference, there will be flow of charge. Obviously there is a flow of charge, the charge will flow from higher potential to lower potential. That is for positive charge I am telling. Okay, for negative it will be from lower to higher. Okay, that is okay. My concept is that my question is that basically suppose my charge is flowing from one conductor to another conductor due to the potential difference. My question is that at when this charge like flow will stop. That is my question. When this charge flow is going to be stopped? Whether I am giving you two options. First option is when the charge will become 0 equal to when the total charge due to them is become same. Means what I am trying to say, when the total charge due to the first sphere and the total charge due to the second sphere is become equal, or when the potential of both of the conductor will become same. That is the two conditions. So which of the option will be correct? Correct option is when the potential of these two will become same. Basically charge transfer is happened due to the potential difference now, because there is a difference in the potential. So when the potential of these two conductors will become same, automatically the charge transfer will stop. So suppose I have two conductors, one conductor has some higher potential and one conductor has lower potential. So obviously there will be charge transfer from the higher potential to lower potential until and unless the potential of these two conductors will become same. And that is what we have did. Initially it has a potential of, suppose it has a conductor which has a radius of r and the total charge is 4q, and it is a conductor whose radius is 2r and the charge is small q. So basically the potential of initial potential is k 4q by r and the initial potential of this is kq by 2r. So what will happen, that there will be charge transfer will take place until the potential will become same. So basically suppose that as it is at higher potential, So charge will transfer from here to here. So we will write the potential of these two and equate it, and you will get that the charge transfer is 7q by 3. And if you put the 7q by 3 value here, you will get the final charge on this will be 5q by 3, and here the charge will be 10q by 3. So as you can see, both the charges are not same. But if you calculate the potential, the potentials are exactly same now. So that is a concept only. If we are conducting two spheres or two conductors, the total charge transfer will be equal to how much? How much will be the total charge? No. When will be the charge transfer will stop? The charge transfer will stop when the potential of both the conductors will become same. Correct? That is a small concept. I hope everyone know this concept. And this is a one example for you. If what we have given, we have just connected these two conductors, and I am asking how much is the charge transfer is there. Okay, that is a simple question. As I solved here, you can see this question, and you can basically what I did, I have to write the potential at this point and this point, and you have to simply equate this, and that is what I have did. I have written the potential at A and the potential at B and just equated it, and after the equation I got that my charge transfer is this much, and then I have draw the simple charge distribution, and that I explain you how to distribute the charge, and you can simply draw it. It is a very simple example. Just take a look of this. If you are not able to understand, just put into the comment box, I will explain it again. Okay, but if you understand this thing, if you have understand this thing, then for you this thing is very easy only. There is no need of something else. Now the next concept we are seeing is the concept of the ground. Concept of the ground is very simple. Basically, concept of the ground simply state that if there are the two, if you are connecting any conductor with the ground, the total potential of that conductor will become automatically zero. Just give me a 1 minute. Yeah, sorry, what I am saying, whenever you are connecting the two conductors with the ground, the total potential of that conductor will become automatically zero. So suppose I am giving you one question. What is the question is there? That is a homework for you. I am giving that question. Suppose initially the system was like that. There is a charge q is there, and there is a charge 2q is there. Okay, I have connected that conductor to ground. What will happen? You have to tell me what is going to be happen. Are you getting my point? I am asking, I have connected this conductor to the ground. So what is going to be happen? Basically, what will happen? Or let me solve for you. What is going to be happen here? Can you tell me what is going to be happen here? Basically, what is going to be, suppose this is my A and this is my B. Basically, potential at A will become zero. That is the only thing. What is the potential at A? Potential at A is K, Q. You have to find the charge distribution. Basically, finally, what is going to be the thing? As you connect this conductor, something is going to be, because see, charge transfer or something will happen, so that to make the potential of this conductor will become zero. So suppose some charge transfer take place, some charge flow somewhere, I don't know where, but there is a no path to that charge can go from here to here. Obviously this cannot be possible. Okay, this cannot be possible because they are not connected to each other. So charge transfer like that, this will not be happen obviously. So let's take it as k, like kq by, obviously the potential at this point will be kq by A. And what is the potential due to this charge to 2q? So this will be k2q by, and it is the internal point, so obviously it will be B. Correct? Obviously it will be B. So kq by A is equal plus kq by 2b is equal to 0. So from here, if I calculate, this thing will cancel out. I will get 1 upon A is equal to minus 2 by B. So from here, what I will get? I will get my B is equal to minus 2A. Means my B is equal to minus 2A. Okay, that means B is equal to minus 2A. And then what basically is going to be happen for charge distribution? If I ask you what is going to be happen for the charge distribution, can you tell me what is going to be happen for the charge distribution? Obviously the charge will flow directly to the ground. That is what I had told you, and potential of this will become 0. The potential is this becoming 0, but we are getting a relation in B is equal to minus 2A. So charge distribution will change or something will happen. Can you comment on this? What is going to be the charge distribution? Are you getting my point? What is going to be the charge distribution? We are getting the relation between the B is equal to minus 2A. Okay, this question I have to change. Basically this question should not be like this, because there is a no connection is there. So charge only flow to the ground. There is a no chance that charge can flow from here to here if you are connecting this conductor to this plate. Okay, basically what is the question should be like this. The question should be like this: find the relation between A and B. This should be the question, because charge will, there is a no chance that charge can flow from here to here. This is not possible. Okay, because for that there should be material here, and there should be some connection of with this to this. Then only then charge can flow. So obviously we cannot frame that question. This question can be possible. What is the condition for B and A? So B should be equal to minus 2 times of A. Okay, minus sign if you want you can ignore. So that is a simple example I am taking. I hope it is clear now. If you not, you can tell me. Clear? Okay. Let's take one example. Basically, I want to some chart distribution question I want to solve for you, so that you can get idea about chart distribution for ground. If we have a ground, then how the charge is going to distribute. Let me think about some question for you. This is a one question we can frame. See, there is a problem while framing a question is that I don't know the data. What type of data I am going to take? That is a thing. Whether the answer will come or not, or like in this question, that is a issue. That issue, like sometime that type of questions I frame where not possible to find the relation. Okay, so suppose this is a concentric, center is there. Okay, suppose this radius is r, radius is 3r, or let take 2r only, and this radius is 4r. Okay, for simplification, this is the condition is given. Okay, suppose this surface the charge is minus q. Okay, and suppose this surface charge is plus 4q. Okay, and this surface is connected to ground. So you have to find the charge on this surface. How much charge will be there? As I will connect it to ground, the potential on this will become automatically 0. So you have to find the how much charge will be here to make this potential equal to 0. And how to solve? Very simple. What you have to do? Make the potential of this surface equal to 0. This is point C. You have to make this potential equal to 0. So there is a potential due to this, this, and due to this. Okay. First due to minus q. As minus q it is outside point, so k minus 2q divided by what is the distance? That distance is 2r. I hope it is clear. Then k q dash. What is the distance? The distance is again 2r. Correct. Then we have a 4q. It is an internal point, so k 4q by how much? 4r. That should be equal to 0. Now from here you can say obviously k will cancel out, r we cancel out, 2 will cancel out, and what is else we will get? We'll get minus 2q, then we will get q dash, and we will get 2q is equal to 0, and from here you will get my q dash is equal to how much? 0. So total charge on this will become, this surface, what is the charge? That is 0 coulomb. Yeah. So if what will be the charge distribution? This is minus q, this will be plus 2q. As initial charge is 0, so here we will have a minus 2q, and here we will have a plus 2q. As initial charge is 4q, so this has to be plus 2. This will be the charge distribution happen. I hope you understand. Okay, because the total charge has to be conserved initial as well as after. The potential applying a ground or before whatever the charge, and final also whatever the charge has to be conserved, because charge cannot go anywhere by itself. Okay, there should be path. Clear? I hope it is clear now. Anyone have a doubt? You can tell. Clear? And there is a one small concept we are left with. Let me tell you that concept also. Shorting two conductors. Short conductor. Basically in this concept, what we are going to see is, suppose I have a one bigger conductor, I have a one smaller conductor. Correct? This is a scenario. And what I have did simply, I simply just connected these two conductors by a wire. Are you getting my point? What I have did? Basically, I have just connected these two conductors with the wires. Okay. Suppose initially the charge is Q1, initially the charge is Q2, and suppose the radius of this is my center and the radius is R1 and the radius is R2. I have just connected them. Then I am asking, obviously there will be something will happen and some charge flow will happen like this. Suppose the charge like minus x will flow from here and it will go to like it will go to here. So what is basically going to be happen? Well, obviously their potential has to be same. So let us make the potential of A equal to B. That is what we have to do. So potential of A equal to B, that is a concept. So let's apply that concept here. The potential at A is equal to K Q1 minus X divided by what is the value R1 plus what is the potential due to this K Q2 plus X divided by how much is the potential due to this charge at this point, at point A, that is R2. Now let us find the potential at this point. So K Q1 minus X divided by R2 plus K Q2 plus X divided by R2. I hope there is no doubt. So which part is getting cancelled out? Can anyone tell me? These two will get cancelled out. So what is we got from here? KK will get cancelled out. So you will get Q1 minus X by R1 is equal to Q1 minus X by R2. Just multiply it. You will get Q1 into R2 minus R2 into X is equal to Q1 into Q1 into R1 minus R1X. Basically from here what you will do, you will go, Q1 is also here, you can take R2 minus R1 and here you can in R2 minus R1. Okay, so I will take this as this side minus X and this will become equal to 0. From here X is equal to, means what you understand, the charge Q1 will flow from, means what is the final charge here? 0. And what is the final charge here? Q1 plus Q2. So what is the concept you got? Whenever we are connecting the two conductors directly, then it will behave as a one conductor, because this conductor final charge will become 0. All the charge from this conductor will flow onto the outer conductor. So they will behave as a one conductor. So total charge will become Q1 plus Q2. That is a concept we have to understand. Clear? Any doubt is there? Okay. So basically now we have completed all the concept regarding the conductors. There is no concept is left. Not a single concept. I have touched each and every concept. Not a single concept I have left. So basically this is how we have completed our conductors. In the next session we will calculate energy density, that is electric field energy density. We will talk about something about that. That is a very small topic. And then we will start our next chapter, that is current and electricity. Before starting our next chapter, we will try to do some more basically some previous year question we will solve, so that so it is better. Now you can revise all the things whatever we have covered till now, because next session is going to be not more than 30 minutes. That we will cover the energy density, and that is a very small topic only. And then we will solve all the previous year questions. So for you, I am telling you, now go and revise everything. Okay, and now you can pick the module of any coaching institute or any book, whatever book you think. But if you want suggestion from me, it is better you take SC Verma and start solving SC Verma. And if you have any doubt, we have our WhatsApp group link. I hope you have joined it. If you don't, join it. And if you have any doubt, just put it into the group. We will answer you as soon as possible. Okay, just put it into the group. We will answer your all doubts as soon as possible, and try to solve all the SC Verma questions. Okay, see SC Verma, sir, what there is a book, go into the electricity, try to solve all the example. If you want, we can go for the discussion of SC Verma also, and if you want, we can solve Irido also. Okay, that we will do, but we will do after when we cover most of the portions, because I have started from class 12th. There will be another there will be after some time you will get the class 11th lectures also. So when we cover some class 11th portion and class 12th portion, then we will move to the Irido. Okay, then we will solve Irido. But now for or now if you want to make your concept, now it is the best time to solve SC Verma. Basically just go and revise each and every concept properly, everything, okay, whatever we have covered till now, and just start solving questions. Okay, I have covered every concept, not a single concept has been left. Total, if you see the PPT, this PPT is of 136 pages. Basically in next session I am going to add more 5-6 pages, so it will become almost 140 page PPT. Okay, and this we will share to you, and I have written each and everything from my hand only. So if you can see, so we are doing this much of hard work for you, just so that you can go into your dream colleges. Now it is a time for you to basically to study and to get your dream college. Okay, we are providing everything for you, whatever you need. So in the next session we are going to cover that small topic, and then we will solve all the previous year question. And if you want the solutions for the different books also, and if you want me to discuss those books, you put it into the comment box. I will surely discuss it. And if you want me to solve Irodo also, I will take the Irodo book and I will write the question and I will solve it properly. Okay, there will be no PPT, nothing by like that. I will discuss this properly, each and every concept if you want. Okay, so let us start your preparation properly and revise each and everything. And just we want only one thing from you, that you like this, you subscribe it, and you share it as much as you can share this thing, because this will reach to the large number of students and it will going to help large number of things, and that will be the motivation for us also. Okay, so till then, take care, goodbye, and have a nice day. Thank you.